We are lumping 5.2 and 5.3 together. So the first question deals with the area of a circle. So area is equal to pi r squared. So here the radius is 8, and it wants us to use 3.14 for pi. So area is equal to 3.14 times 8 squared. And then you're just going to plug that into your calculator. Let me see if there's a different type. Okay, same idea, but now it gives us the diameter is 8, which means that the radius is 4. So 3.14 times 4 squared. Then plug in the answer. All right. So here I have a pie chart. It's divided into a bunch of different majors. Each major has a percentage, and it wants to know what is the angle of the piece of pie for sociology. We call this angle the central angle. So anytime you have an angle that originates in the center of a circle, that is called a central angle. And we know that the entire circle is made up of 360 degrees. We also know that the sociology portion of the circle represents 24%. So the central angle for sociology should be 24% of the full 360. So I times this by 0.24. So 360 times 0.24 gives me 86.4 degrees. Do you guys want to see another one of those? Yeah? Okay. All right. Here we know that the central angle for Choi is 93.6. Oh, this one's kind of complicated. There were 6 candidates, 4,700 total votes. How many votes did Choi get? So this is a certain percentage of 360. So to figure that out, 93.6 divided by 360 is going to give us, so 93.6 divided by 360 gives us 26%. So how many votes did he get, or she, I guess? 26% of 4,700. So we times that by 4,700, and I get 1,222 votes. Okay, let's do another one. "1,200 people were asked to name their favorite sport to watch. The circle graph below summarizes their answers. The soccer slice is 111.6. What percentage of the people named soccer as their favorite sport?" Okay, so we have this angle is 111.6, and that's out of a total of 360 degrees. So 111.6 divided by 360 gives me 31%. And it says, what percentage of people named soccer as their favorite sport? So this doesn't want to know how many people, it just wants to know the percentage. So the percentage is 31%. Do you need to see any more? You good? Okay. All right. So here we have two chords. We have two radii, and we know that the chords and the radii intersect at right angles. Okay. We know that the distance of QR is 19. We know the distance of SR is 3x plus 1. We also know that ZU, this length here, is 12. And ZV is this length here, which is also 12. Because of that, we know that the two chords are the same length. If this distance is equal to this distance, then these two chords have to be the same length. So 3x plus 1 is equal to 19. And then we just solve. 3x equals 18. Let's divide by 3. So x is 6. Okay. And then it wants to know, how big is this? Well, if a radius intersects a chord at a right angle, then that chord is cut into two equal halves. So this length and this length are the same. And together, they equal 19. So cut in half, it would be 8.5. All right, let's do another one. Oh, wrong button. Okay, same idea here. QR, this length is 20. TV, this length is 10. SV, this length here, is 2x plus 2. And VZ, this length here, is 7.5. How big is UZ? Well, this length is 20, and this length is 10, which means that length is 20. And that tells us that these two sides are the same length. So if VZ is 7.5, then UZ is also 7.5. And then those two are equal. 2x plus 2 is equal to 10. Subtract the 2. So x is 4. Right. Okay, and so arcs. In mathematics, an arc is not just any curved line. An arc is a piece of a circle. So in order to be an arc, that piece has to fit perfectly on a circle of some specific size. So if I have a circle and I put 2 points on it, I sort of divide the circle into two arcs. I have a small arc we call a minor arc, and then I have a big arc we call a major arc. So a minor arc is less than half of a circle. A major arc is more than half of a circle. And if my 2 points lie on a diameter, then I don't have any major or minor arcs. What do we call these? What do we call an arc that's half a circle? You probably have heard the word before. No? Semicircle. So if the arc is half of a circle, we refer to it as a semicircle. All right. So how do we name arcs? Well, if I give these points labels AB, the arc AB always represents the minor arc. So if you label an arc with 2 letters, that is always the little one. Can you remember that? How do we do major arcs? In order to label a major arc, we need another point. And then that point goes in the middle. So I could start over here and say arc ACB. So arc ACB, or if I go in the other direction, it would be arc BCA. And that's a major arc. All right? Okay. So in a minor arc, that minor arc can be measured using the central angle. So what is the measure, what is the degree measure of that minor arc? So we'd say the minor arc is equal to 63 degrees. That's how many degrees of the circle that arc covers using the central angle. What would the other one be? Well, 360 minus 63 is 297. So the measure of this arc is 297. All right. So, give a central angle. This would be a central angle, and we always label angle using 3 points. So LKM. Give a minor arc. A minor arc could be listed picking any 2 points that are not on a diameter. So ML would be a minor arc, NM would be a minor arc, PL would be a minor arc, but we could not say LN because that's a semicircle. Okay. Give a semicircle, LPN, or we could do NML. There are lots of different answers. What is the measure of LM? So it wants to know how big is this arc? 75 degrees. Okay. How big is LMN? So LMN is a semicircle, so that would be 180. What is the measure of arc MLN? So how big is this arc? How would you do that? How would you calculate that arc size? Good, yeah. So this piece is 180, and this piece is 75, so it would just be 75 plus 180, which I believe is 255. All right, that is it. Get to work.